Hey guys, today we're learning about the chain rule. Remember, each of these rules, they're not there to add extra stress to our life, to add just one more thing to do. Each of these rules are here because they are shortcuts. For instance, here we have x plus 1 to the third power. This is a perfect example of when we would use it. You have an equation on the inside with an exponent on the outside. You have an equation f of x to the nth power. All right? Without the chain rule, it would take a lot of steps to this problem, to be honest. But because we have the chain rule, we can use the shortcut and blow through it really quick. So, when you take the derivative, you just bring n down, like you would do with any derivative. Bring your exponent down. You have your f of x to the n minus 1 power. So far, it's the same as taking a derivative of a polynomial. The only difference is on the outside, we take the derivative of whatever x was, f of x. So let's do an example, okay? If I had, let's say x to the fourth, the derivative would be, you bring the 4 down, so 4x cubed to whatever x was, the derivative of x, okay? I'm just gonna write x prime, because if x wasn't an actual x, it was really some function in parentheses, just take the derivative. Well, let's try doing this without the chain rule, just to see that we can do it. So if we're going to do this, this is really, if you're cubing it, x plus 1, x plus 1, x plus 1. If I go through, I'm going to have to distribute. That gives me x squared plus 2x plus 1 times x plus 1. Oh, I'm already tired. By this point, I'd already be done if I was using the chain rule. Just saying. Okay, now I gotta distribute all the way again. They all have to go all the way through twice. That gives me x cubed plus 1x squared plus 2x squared plus 2x plus 1x plus 1. Oh, this is taking forever. The chain rule would have been so much faster. Okay, well, we still are at h of x. We haven't even started taking the derivative yet. And in fact, we have to simplify this before we can take the derivative. H of x equals x cubed plus 3x squared plus 3x plus 1. Now I can take my derivative. H prime of x is going to be 3x squared plus 6x plus 3. Okay? Oh, can you even see that low? Yeah, you can. You can just barely see that low. So that's if we don't use the chain rule. Let's use the chain rule. So we bring the 3 down. That gives me 3x plus 1 squared times the derivative of the inside. What's the derivative of x plus 1? It's just 1. What's 3 times 1? It's just 3. Ta-da! You're done. All right, let's try this problem. We have negative 2x plus 5 to the 9th. We want to go through and figure out what is the derivative. So, we're just going to do the same thing that we did the last time. We're going to bring the 9 down, so that's going to give me negative 9, 2x plus 5, n minus 1. So 9 minus 1 would be 8, times the derivative of the inside would be 2. Can I simplify the 2 and the 9? Absolutely. That gives me negative 18. 2x plus 5 to the 8th power. You're done! That's it! Well, I mean, we've got to write f prime of x. But that's it! Alright, let's try this one. This one's going to be a little bit trickier. This is the first time that you've seen fractional exponents, I believe. Possibly. Okay, let's give it a try. We're going to bring the 1/2 down. Negative 4 times 1/2 is negative 2. We've got the inside x squared plus 3x plus 2. What's 1 less than 1/2? Be negative 1/2. Okay? Yes, there's such a thing as negative exponents, in case you didn't know. All right, now we have the derivative of the inside. The derivative of the inside is 2x plus 3. You know what? You can just leave it like that. You don't have to do anything else. I realize it's 3 separate parts. Just leave it. You're fine. All that we want to know is, can you take the derivative? Can you use the chain rule? Alrighty, let's try this problem. Take a quick second, write it down, pause it if you need to. Okay, we're gonna use the chain rule. We're gonna take our exponent, multiply it by -10. What's 3/5 times -10? Well, 10 divided by 5 is 2. 2 times 3 is -6. Okay, so we got -6. 4x to the 7th minus 3x squared times, well, not times, but to the, what's 1 less than 3/5? -2/5. Now we have to multiply by the derivative of the inside. That would be 28x to the 6th minus 6x. You're done. And you can see with a problem like this, where you would have to multiply this by itself 3 times, then take the 5th root of it, it would get a little complex. So using the chain rule makes this go super, 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 super slick. I'm gonna do one more example. I want you to give it a try. Actually lied, I'm gonna do one more example problem of what you can do with the chain rule, then I'm gonna let you do your own. So here's another problem. If you look, there's actually 2 sets of parentheses. Okay, so what we're gonna do is we're gonna take the derivative, h prime of x. Remember, we're gonna bring down the exponent, so we're working on the outside first. 4 times 4 is 16. I'm gonna leave the inside alone, which is x squared plus 3x squared to the 3rd power. Now we take the derivative of the inside. The derivative of the inside would be, ooh, looks like we're gonna have to do the chain rule again, because we're gonna have 2 times x squared plus 3x to the 1st power. But remember, since we did the chain rule, we now have to multiply it by that again. That gives us 2x plus 3. So whenever you got the extra one, you just keep doing it again and again and again and again until you get all of them done, okay? All the different sets of parentheses that are nested inside of each other. Don't worry, your problem won't be that hard. All right, this one is your turn. Give this problem a try. Okay, you should pause the video. You should have the answer by now. Let's give it a try. So we're going to take the 5/4, we're going to multiply it by 4 to get our derivative. That's going to give me 7w4 minus 3w squared. What's 1 less than 5/4? It would be 1/4. Times the derivative of the inside. That's going to give me 28w third to the 3rd power minus 6w. And you're done. That is it. You have just done the chain rule. You didn't have to worry about the crazy exponent and trying to figure out how do you multiply it by itself 5 times and take the 4th root. It just sounds horrible. Okay? Anyway, that is the chain rule. Good luck.